Welcome back to Quantitative Methods. In our previous lesson, we learned how rates and returns help us evaluate investment performance. Now we will use those ideas to answer a new question. What are future cash flows worth today? That is the foundation of the time value of money. Hi, I'm Brandon, your Everest exam prep AI coach. If formulas have ever felt intimidating, this lesson is designed to make them manageable. We will move from the intuition to the equation, then from the equation to an exam-style question. By the end, you will be able to price cash flows, interpret implied returns, and recognize how no arbitrage connects the pieces. Our objectives are straightforward. First, calculate and interpret present value for fixed income and equity cash flows. Second, solve for implied returns, required returns, and dividend growth from observed prices. Third, understand cash flow additivity and why it supports no arbitrage pricing. Throughout the lesson, we will pause for worked examples and solve each one step by step. The central idea is simple. A dollar received today is worth more than a dollar received later because today's dollar can be invested and can earn a return. Present value reverses that growth process. Instead of compounding today's money forward, we discount a future cash flow back to today using an appropriate rate that reflects timing and risk. The basic future value relationship is future value equals present value multiplied by 1 plus the rate raised to the number of periods. To solve for present value, rearrange it. Present value equals future value divided by 1 plus the rate raised to the number of periods. For example, if you will receive 100 in 1 year and the discount rate is 5%, present value is 100 divided by 1.05, or approximately 95.24. Fixed income instruments are a natural application. A discount bond has one payment at maturity. A coupon bond pays periodic interest and returns principal at maturity. An annuity makes level payments over a finite number of periods. The valuation method is the same in every case. Identify each cash flow, discount it using the appropriate rate, and add the present values. For a discount bond, present value is the future principal divided by 1 plus the market rate raised to maturity. The difference between the price paid and the principal received is the investor's return. A coupon bond adds the present value of every coupon to the present value of principal. An annuity discounts a series of equal payments. The key exam skill is matching the cash flow pattern to the correct formula. Let's work through a discount bond question. Suppose a zero coupon bond pays 100 at maturity in 10 years, and the annual discount rate is 6%. The question is not asking for the return, it is asking for the price today. So we begin by writing the present value formula, identify the future value, rate, and number of periods, and then substitute each input. Now solve it. Present value equals 100 divided by 1.06 raised to the 10th power. Evaluating the denominator gives approximately 1.79, so the price is about 55.84. The interpretation matters. The investor pays roughly 55.84 today to receive 100 in 10 years. The lower price compensates the investor for waiting and reflects the 6% required return. Equity valuation uses the same present value logic, but the cash flows are dividends rather than contractual coupons. A constant dividend is a perpetuity. A constant growth model assumes dividends grow forever at a stable rate. A two-stage model separates an initial high growth period from a later stable growth period. The model you choose must match the company's expected cash flow pattern. For a constant dividend paid forever, price equals the dividend divided by the required return. For constant growth, the Gordon growth formula is price equals next period's dividend divided by required return minus growth. The condition is important. Required return must exceed growth. A two-stage model first discounts the individual high-growth dividends, then discounts the terminal value created by the stable growth phase. Here is a practical stock valuation question. A company is expected to pay a next period dividend of $1.50, growing at 6% indefinitely. If shareholders require a 15% return, what should the share price be? We know the Gordon growth model applies, so the solution begins by identifying next period's dividend, the required return, and the growth rate. Substitute the inputs. Price equals $1.50 divided by 15% minus 6%. The denominator is 9%, so the value is $1.50 divided by 0.09, which equals approximately $16.67. Notice the sensitivity. Increasing the required return widens the denominator and lowers price, while increasing sustainable growth narrows it and raises price. So far, we have used a discount rate to find a price. We can reverse the process. When price and future cash flows are known, we can solve for the return implied by that price. For a discount bond, the rearranged formula is the future value divided by present value, raised to the power of 1 over the number of periods minus 1. For coupon bonds, yield to maturity is found iteratively. For a growing stock, implied return equals expected dividend yield plus growth. Suppose the share price is 63, the next dividend is $1.76, and growth is 4%. Dividend yield is 1.76 divided by 63, or about 2.79%. Add 4% growth, and the implied return is approximately 6.79%. If the required return is 7% instead, implied growth is about 4.21%. The final connection is cash flow additivity. If two future cash flow streams occur at the same times, the value of the combined stream equals the sum of their individual present values. This principle supports no arbitrage. Economically equivalent strategies should have the same price. If they do not, an investor can buy the cheaper strategy, sell the more expensive one, and lock in a riskless profit. Let's calculate an implied forward rate. A 1-year rate is 2.5%, and a 2-year rate is 3.5%. The 2-year strategy grows 100 to approximately 107.12. Set that equal to 100 times 1.025 times 1 plus the forward rate. Solving gives a 1-year forward rate of approximately 4.51%. Any materially different rate could create an arbitrage opportunity. Cash flow additivity also explains forward exchange rates and option values. In foreign exchange, investing directly in dollars should produce the same future dollar value as converting into another currency, investing there, and converting back using a forward rate. In option pricing, we build a replicating portfolio whose future value is identical in both possible states. Then we discount that risk-free payoff. For the call option, the asset is 40 today, rises to 56 or falls to 32, and the strike is 50. The call payoff is 6 in the upstate and 0 in the downstate. Buy 0.25 units of the asset and sell the call. In both states, the portfolio is worth 8. Discount 8 at 5%, then solve. 10 minus the call price equals 8 divided by 1.05. The fair call price is approximately 2.38. When you see a time value of money question on the exam, slow down and classify it before calculating. Is it one future cash flow, periodic coupons, level payments, dividends, and implied return, or two equivalent strategies? Write the timeline, convert annual rates to the correct periodic rates, keep the signs consistent, and only then enter the formula. This process prevents most avoidable errors. Let's recap. Present value discounts future cash flows using an appropriate rate. Bond valuation depends on whether cash flows are discount, coupon, or level payment patterns. Equity valuation depends on dividend assumptions and growth. Implied return and growth reverse the valuation process. Finally, cash flow additivity links equivalent strategies and protects the no arbitrage condition. Use the workflow: question, timeline, formula, substitution, and interpretation. Time value of money can feel challenging at first because it introduces concepts used across equities, fixed income, currencies, and options. Don't worry if it doesn't click straight away. You'll revisit these ideas throughout fixed income, equity valuation, economics, and derivatives, and each time they'll feel more familiar. In the next lesson, we will build on valuation by focusing on how risk and uncertainty affect expected returns and portfolio decisions. For now, practice each worked example until the timeline and formula feel automatic. Keep using your Everest study planner, stay consistent with your question practice, and remember, small, repeatable steps create exam day confidence. I'll see you in the next lesson.